You work for a construction company and you need to be able to lift a bundle of bricks from the ground up to the top of a building. You suspect that you'll need to use a pulley for this, but the question is, how many pulleys do you need? Will one be enough? Is two better? Maybe three? What we're going to do in this activity is we're going to measure the force required to lift something that represents the bricks and see which one of these systems is better for this problem. This weight is going to represent the bricks that we need to lift to the top of the building. I'm going to attach this force sensor to the bricks. In every case, we're going to lift these bricks the same amount. So over here I have a ruler. Let me lift the bricks up 5 centimeters and hold them as steady as I can. You look on the screen, it looks like the weight of the bricks is about 4.9 newtons. Okay, so let's record that and keep that handy for later. So here I have a system that has one pulley, and then what I'm going to do is I'm going to take the force sensor and I'm going to connect it to the other string. Let's lift them 5 centimeters. The system is asking how many strings are holding up the weight. If you notice, one string is actually holding up the weight of the bricks. So I'm going to type in 1. If you look at the data, you'll see that the force applied, 4.79 newtons, is very close to the original weight of the bricks. But in this system, you'll notice that the force was applied in the opposite direction that the weight moved. So this single pulley changed the direction of the force. What happens if we have the weight lifted by 2 strings? We have a string up here where the pulley was before. The pulley is free to move, and there's another string here. Both of these strings are attached to our bricks. Let's lift the bricks the same amount, 5 centimeters. The system is asking how many strings are holding up the weight. Well, in this case, there are 2 strings holding this weight up. So let me type in 2. And then let's take a look at that data. The original weight was 4.9 newtons. With 1 string, the force applied was 4.79 newtons. But with 2 strings, the force that we have to apply is 2.6 newtons. The weight hasn't changed, but what's happened now, 2 strings are sharing the weight of the bricks. So this is requiring us to apply less force. What happens if we increase the system to 3 strings? We have 3 strings holding up our bricks. Let's do the same thing we did before. So every time we're going to lift the bricks 5 centimeters. You may notice that I'm pulling this outer string further than ever. So let me lift that up 5 centimeters and hold it as steady as I can. Now I have 3 strings holding up the weight. We can see that with 1 string supporting the bricks, the only effect was to change the direction of the force. The amount of force applied was nearly the same as the weight of the bricks. With 2 strings holding up the bricks, each string held about half the weight of the bricks, and so we only had to apply half the force. We paid for that by having to pull the string further. In the case of 3 strings, we applied a fraction of the original weight of the bricks. The bricks' weight didn't change. The amount of work done on the bricks to lift them was always the same, because we always lifted the same bundle of bricks 5 centimeters. However, in the 3rd case, we applied only 1.6 newtons of effort force to lift the bricks the 5 centimeters. So we had to apply the force over a larger distance. We did 3 pulleys, 2 pulleys, 1 pulley. What if we did more pulleys? If the system was more complex, would that make it easier to lift the weight? Would it make it more efficient if we used more pulleys? It's something for your students to try out.